All right, ladies and gentlemen, I think this is the one last topic that I didn't manage to explain in the other video. So for example, you will, if the question requires you to, draw graph, find intersection. What do you do here? All right, these are, this is drawing a graph, and look, method number one is probably going to be a lot harder since we never actually drew multiple graphs. I'll show you the first method. First method is first of all, make sure when you are drawing graph, your mode need to be, get back to approximate, okay? It can create all kinds of issues if you're drawing in the exact format. So where do we need to go? We need to go to this. Okay, in here, you're drawing, f1 of x. Now, a lot of you gets a little bit intimidated by those kind of notation, but that's how graphs will look like as you move into year 12 and beyond. What this is trying to say is function 1 of x. So for example, that equation here, there is function of x. This is a function of x. It's simply, we're using y to describe that. But y in reality is a function of x. So f of x is how they denote these expressions. Okay, well, what does the 1 mean? Well, that means this is the first equation of such. This would be f2 of x. Okay, so let's draw this one here. I mean, f of x, f1 of x is the same as y1 equals to 3x plus 8, so to speak. So 3x plus 8. Okay, you got this graph drawn. Don't worry about the zoom just yet, no worries. Because the next one here, 2x minus y equals to 5, is a bit more difficult. How on earth do you actually draw both graphs on the same axes? I believe I may have explained it in class, but that was a long time ago in this galaxy. You press tab. That's right, you press tab. Anytime you want to create a new graph, you press tab, okay? You press delete, remember this? Number 6 gives you relation. We simply need to have this. And what do we do next? You simply type this in exactly as it's required. So 2x, right? 2x minus y equal to 5. Okay, you get this going here. Now, well, we've got a bit of a problem. Okay, we've got a bit of a problem. The zoom is really bad. So you go to zoom. I mean, obviously we need to zoom out. Wait, how? So press exit if you don't want to, if you don't want to zoom any further. I want to zoom out. You need to choose a center. I mean, this looks like a center. We need to go down a bit more. There we go. Maybe a bit more. There we go. Now that we seem to have a little center. Now, remember we said we want approximate value. If we had chosen exact value, you would have gotten things like 8,585 over 100 or something to that effect. Something ridiculous. Now, we want the middle value between the two. You go menu. Now, here's the hard part. Analyze graph, intersection. And you need to say, well, where's the intersection between? Well, it seems to me it's about here. So it's somewhere here. Choose 2 points. Choose 2 points wherever it needs to be. Boom. I mean, it doesn't have to be that wide. Okay, it seems to me our intersection is at negative 13 and negative, 31. So that value here, if you haven't noticed, that value would be exactly the same answer if you simply had solved both of these equations. So if we're going to draw this graph here, I mean, roughly drawing, of course, I'm not going to be very accurate. The very first thing you need to draw is basically, well, where the two graph intersects. So it seems to me they intersect somewhere here. I mean, like, it doesn't have to be anything genuinely, as long as you get it reasonably accurate, then life is good. Okay, this point here, you need to clearly label -31. Okay, so you need to do this first. Okay, next, very important, is basically the x and y intercept. Now you could do it on the graphics calculator itself by doing things called trace. Okay, so if I trace, look at this. If I trace this, I got a 0. The 0 would be negative, if I keep going up, there we go, hang on. Y-intercept 0, 8. So the other one is, but how do we get the intercept of the other two? There we go. You press up and down. Press up and down. Up and down means change the graph from the first to the second. So the y-intercept of the second one here is 0, -5. Press left and right. Let's keep going again. 0 once again. You've got 2.5. Okay, and so you've got this graph here. But I mean, goodness gracious me, I got confused in that little passage of play myself. So in the exam, I can just imagine how chaotic this is. How about this? How about let's just stick to what do we know using the basic graphing function. So stuff the calculator now. Let's not worry about the calculator now. So for this one here, y-intercept x equals to 0. Well, if x equals to 0, y would simply be, x equals to negative y equals to 5. Y equals to 5. Okay? Well, what about the x-intercept? X-intercept, y equals to 0. If y equals to 0, well, 2x equals to 5. X equals to 5 over 2. That's exactly what we got here. Look at this. Look at this. Boom, boom, x over 2. There we go. Now let's go into this particular graph. Let's have a look at this one here. The y-intercept, that in itself is the y-intercept. 8. That's exactly what this is. Tick. What about x-intercept? Well, y equals to 0. Y equals to 0. X, x-intercept, -3x equals to 8. Equals to -8 over 3. I mean, -8 over 3 is basically 2 2/3. -2 2/3 if you do a bit of fraction. I'll just put in the calculator. Boom. You got that. Done. Okay, this is the much easier method for you. I mean, this is if you knew how the graph is drawn, but between that method and what's going on here, you'll probably find much more luck doing this. You can, something like this. I just thought to explain this in specifically for the exam. All right, try some of this. Try this question. Make up some of your own numbers. See what happens. All right, thank you.